Imagine this, a billion-dollar air defense system, advanced radar, precision interceptors, combat proven, and still a missile gets through. Not once, not by accident, but repeatedly. How does that happen? How can one of the most advanced missile defense systems on Earth still fail to stop everything? The answer is uncomfortable, because Patriot was never designed to stop everything. It was designed to manage risk, and those are not the same thing. So when most people hear the word missile shield, they imagine a dome, an invisible wall in the sky. Nothing gets in, everything is stopped. That image is powerful, it is also wrong. Patriot is not a shield, it is a battery, a system of radar, launchers, control units, and interceptors working together under pressure. It does not create a dome, it creates a probability. The radar scans the sky, it tracks incoming objects, it calculates trajectories, it prioritizes threats. But here's the first crack in the illusion. The radar cannot track infinity. Every radar has a limit. Every processor has a capacity. Every operator has a reaction time. In controlled tests, interceptions look clean. One target, one solution, one interceptor, one explosion in the sky. But real battlefields are not controlled tests. They are messy. Multiple objects, different speeds, different altitudes, electronic interference, decoys, drones, ballistic missiles, cruise missiles, all at once. Now imagine the radar screen. Blips begin to appear. 1 becomes 5, 5 becomes 10, 10 becomes 20. The system must decide which ones are real, which ones are decoys, which ones are critical, because here is the second crack in the illusion. Patriot does not have unlimited missiles. Each launcher carries a finite number of interceptors, 16 smaller interceptors, or fewer larger ones, depending on configuration. When they are gone, they are gone. Reloading takes time. And time is the one thing you do not have when missiles are inbound. This is where expectation collides with design. The public expects perfection. Engineers design for survivability. Those are different philosophies. Air defense systems are built on trade-offs. Coverage versus density, mobility versus firepower, cost versus probability. Patriot was designed during the Cold War. Its original purpose was specific: defend key assets, airfields, command centers, population hubs. Not entire countries, not infinite skies. A Patriot battery protects a zone. Not everything, just something important. And here is the third crack, the geometry problem. Missiles do not approach from one direction. They can fly low, they can hug terrain, they can approach from multiple azimuths. Radar coverage is not a perfect sphere. It is shaped by terrain. Buildings, curvature of the earth, low-flying cruise missiles can appear late. Very late, sometimes seconds before impact. At that moment, the system must detect, classify, calculate, launch, all within a shrinking window. Now ask yourself something simple. What happens if 5 targets appear simultaneously inside that window? The system must choose, because interceptors are not cheap. Each launch costs millions. Each shot is a decision, and no commander fires blindly. This is not about incompetence, it is about physics. Tracking capacity is finite. Engagement channels are finite. Interceptor inventory is finite. Reaction time is finite, but the sky is not. When analysts say Patriot missed, they simplify something complex. Sometimes it misses because it was saturated, sometimes it misses because the threat profile changed, sometimes it misses because the system was protecting something else. Air defense is not about stopping every missile, it is about protecting the highest value asset. If 10 missiles come in and 9 are intercepted, and 1 lands in an empty field, is that failure or is that acceptable loss? This is the uncomfortable part. No air defense system is built for perfection. They are built for probability management. The illusion of total protection exists because marketing is simple. Reality is not. Patriot can intercept ballistic missiles, it can engage aircraft, it can destroy cruise missiles, but it cannot create infinity. And that is where the misunderstanding begins. When people see one missile get through, they assume weakness, but in military logic, the question is different. How many got through, how many were stopped, what was being defended, and at what cost? Because here is the truth. Air defense is not a wall, it is a filter. And filters always let something through. The real question is not why did Patriot miss? The real question is what happens when the sky fills faster than the system was ever designed to handle? And that is where the saturation problem begins. The saturation problem does not begin with weakness. It begins with arithmetic. A Patriot battery does not carry unlimited interceptors. Each launcher carries a fixed load. 16 PAC-3 interceptors, or fewer PAC-2 missiles, depending on configuration. Once fired, those tubes are empty. Reloading is not instant. It requires vehicles, personnel, time, and safety clearance. In a live attack, there is no pause button. If 20 incoming targets appear, and you have 16 interceptors ready, math becomes the enemy. Even if every interceptor hits, 4 targets remain. This is not malfunction. It is inventory limitation. Now add another variable. Cost. A single PAC-3 interceptor costs several $1,000,000. Some estimates place it between $3 and $5 million per shot. Now consider the attacker. A simple drone can cost $20,000, sometimes less. A cruise missile can be cheaper than the interceptor sent to destroy it. This creates a dangerous imbalance. The defender spends millions, the attacker spends thousands. Over time, the defender bleeds resources faster. This is called cost exchange ratio, and it favors the side launching cheap volume. Now imagine a coordinated attack. Not one missile, not 2, but dozens. Mixed profiles, high-altitude ballistic threats, low-altitude cruise missiles, slow drones, fast maneuvering targets. Each requires tracking, each requires classification. Each requires a firing solution. Radar systems have engagement channels. They can only guide a certain number of interceptors at once. That number is not infinite. If more threats appear than engagement channels available, some must wait. Waiting means delay. Delay means reduced intercept probability. Now add electronic clutter, weather, terrain reflections, electronic warfare. The radar picture becomes noisy. The system must filter signal from noise. That filtering consumes processing capacity. Even advanced phased array radars have limits. They scan sectors, they allocate beam time. They cannot stare everywhere equally at once. If the attack is synchronized across multiple directions, coverage is diluted. Detection time shrinks. Decision time shrinks. Reaction windows close. Now consider the human element. Even automated systems rely on confirmation layers. Operators monitor data. Commanders approve engagements. Rules of engagement apply. Milliseconds matter. If classification is delayed, launch is delayed. If launch is delayed, interception geometry worsens. Ballistic missiles descend rapidly in terminal phase. Cruise missiles hug terrain. A few seconds can be decisive. Saturation exploits that delay. But the most dangerous tactic is mixing threat types. High-speed ballistic missiles demand immediate priority. They are lethal, they are fast, the system commits interceptors to them. At the same moment, see low-cost drones approach from different vectors. They are slower, they appear less threatening, but they consume radar tracking, they consume engagement slots, they create confusion. This forces triage, which targets are real, which are decoys, which must be stopped at all costs. Every system has a maximum throughput. Air defense is no different. If throughput is exceeded, leakage occurs. This is not a glitch, it is system overload. Consider reload time. After interceptors are expended, resupply vehicles must approach. Launch tubes must be rearmed. That process takes hours, not seconds. If a second wave arrives during reload, the battery becomes vulnerable. Attack planners understand this. They design waves. First wave probes, second wave saturates, third wave exploits depletion. The system does not collapse instantly, it erodes. One interceptor fired, then another, then another. Inventory shrinks, options narrow. Eventually, commanders must decide to conserve. Not every target can be engaged. Some must be accepted. This is the uncomfortable calculus of air defense. Defense is finite. Offense can be scaled. Attackers can produce cheap volume faster than defenders can produce expensive interceptors. In prolonged conflicts, this imbalance becomes strategic. Now zoom out. A single Patriot battery does not defend an entire nation. It defends a point, an airfield, a power plant, a command center. If attackers launch missiles at multiple sites simultaneously, defenders must spread batteries, spread thinner, less density, more gaps. Those gaps are where saturation becomes breakthrough. And remember this, Patriot does not operate in isolation. It is part of a layered system. Short-range systems, medium-range systems, long-range interceptors. If one layer is overwhelmed, pressure shifts to the next. If coordination between layers falters, openings appear. The myth is that a single system guarantees protection. The reality is that protection depends on integration and capacity. Saturation does not require superiority, it requires volume. Enough targets, in the right sequence, at the right time, can overload any finite system. No radar is infinite, no launcher is infinite, no budget is infinite. When observers say Patriot failed, they rarely ask how many targets it faced, or how many it destroyed, or how many waves were launched. They see the one missile that landed, and they do not see the 15 that did not. Saturation is not about breaking the system, it is about exceeding its design envelope. Every system has one, and once exceeded, probability collapses. Not because the system is flawed, but because physics always wins against infinity. The final piece of the saturation problem is simple. Defense is reactive, attack is proactive. The attacker chooses timing. Direction, volume. The defender responds, and response always lags behind initiative. That asymmetry is the heart of the problem. No matter how advanced the interceptor, no matter how sophisticated the radar, if the sky fills faster than the system can process, some things will get through, and that is not failure. That is math. The final problem is not technical, it is philosophical. Patriot was never designed to create invulnerability, it was designed to protect priority. And that distinction changes everything. Air defense is built around trade-offs, coverage versus density, mobility versus protection, cost versus redundancy. You cannot maximize all three. If you concentrate batteries in one area, you increase density, but you create gaps elsewhere. If you spread them out, you increase coverage, but reduce overlapping fire. Every deployment is a compromise. Now consider geography. Terrain shapes radar visibility. Mountains block line of sight. Urban structures create clutter. The curvature of the Earth limits low altitude detection range. At long distances, low-flying cruise missiles disappear below radar horizon. They reappear late, sometimes very late. That delay compresses intercept windows. Now add mobility. Patriot is not a lightweight system. It requires transport vehicles, power generation units, command trailers, radar arrays. Setup takes time, relocation takes time. It cannot redeploy instantly to follow shifting threats. An attacker can change launch sites overnight. The defender must move hardware. That takes planning. And vulnerability exists during movement. Then there is integration. Patriot relies on a broader network. Early warning systems, satellite data, external radar feeds, command and control links. If that network is degraded, Patriot's awareness shrinks. No system operates in isolation. Even the most advanced interceptor depends on upstream data. If communications are jammed or sensors are disrupted, reaction time increases. That delay reduces probability. Now consider redundancy. To guarantee near-perfect coverage, you would need overlapping batteries everywhere. That is financially impossible. Air defense is expensive, missiles are expensive, maintenance is expensive, personnel are expensive. Budgets are finite. This means planners must choose what to defend. Critical infrastructure, military assets, population centers, everything else becomes secondary. This is where perception collides with doctrine. The public sees a system advertised as protection. Military planners see a system designed for risk reduction. Those are not equal. If a Patriot battery protects a base and a missile hits outside the perimeter, was that failure, or was the objective achieved? Defense is not binary, it is statistical. Every intercept has a probability of success. Even under ideal conditions, no interceptor guarantees 100% reliability. Hit probability might be high, but never absolute. Add weather, add maneuvering targets, add electronic interference. Probability shifts. Now combine all variables. Finite interceptors, finite engagement channels, finite coverage, finite budget, finite reaction time. Against potentially infinite attack volume, the mismatch is structural. No defensive system can scale infinitely. Offense only needs one breakthrough. Defense must stop everything aimed at the protected asset. That asymmetry defines modern air warfare. Now zoom out further. What is the purpose of air defense? It is not to create safety. It is to raise the cost of attack. If the attacker must launch 20 missiles to ensure one hit, the defender has changed the equation. If cheap drones are forced to be mass-produced in higher numbers, logistics strain increases. Air defense shifts the economics of war. It does not eliminate risk, it redistributes it. This is why advanced systems still see leakage, not because they are obsolete, not because they are incompetent, but because design constraints exist. You can increase missile speed, you can improve radar resolution, you can upgrade software, but you cannot remove trade-offs. If you double interceptors, you double cost. If you increase radar power, you increase detectability. If you add mobility, you reduce armor and stability. Every enhancement introduces a compromise elsewhere. The myth of perfect defense persists because we prefer certainty. But warfare is not certainty. It is probability management under pressure. When observers say, Patriot failed, they often ignore scale. How many threats were faced? How many were destroyed? What was the objective? What was acceptable loss? So air defense is not about stopping every missile. It is about ensuring that the most important target survives long enough to function. That is success in military logic. Perfection is not required. Survival is. The final misconception is emotional. A single impact is visible. A successful interception is invisible. Explosions on the ground are dramatic. Missiles destroyed at altitude are silent statistics. Public perception is shaped by what lands. So military evaluation is shaped by what survives. When Patriot misses, it does not mean the system is broken, it means the system met its limit. Every machine has one. And in modern warfare, attackers are learning how to find it. So the real lesson is not about Patriot, it is about expectation. No air defense system can create invulnerability. It can only create delay, it can only create cost, it can only create friction. And sometimes that is enough, because in war, you do not need to stop everything. You only need to protect what matters most. The rest is mathematics.